Hello everyone. Today I'm going to show you some trig identities and what you can use them for. Alright, so here we're going to show you some trig identities. Let me pick up this right triangle, and we're just going to make a right triangle, and we're going to do something that you are probably already familiar with, which is the Pythagorean theorem. Okay, so when you are given a right triangle, the Pythagorean theorem states that the square of this number plus the square of this number, in other words, the sum of the squares of the two legs of the right triangle, is equal to the square of the hypotenuse. So that's written in the very familiar a squared plus b squared equals c squared. But that's visually represented like so. So there's a squared. Here's b squared. Oh. And here's c squared. And here's c squared. Right? So the area of this square plus the area of this square equals the area of this square. Now, on a unit circle, we can actually state some other things about this. So let me get right back to you on that. Okay, so on a unit circle, something like this, right? So the unit circle has its center. There we go. Let's say that our unit circle is here, right? With a radius of 1. Let's say the center is here. What that means is that this c, this hypotenuse, again, remember that this is the center right here. So our unit circle means that this is 1. Okay? Also, when you have a unit circle, that changes the meaning of a and b. So a would be the cosine of this angle. So let's say, angle A or whatever. This would be the cosine of A, and erase this. This would be the sine of A. Okay, now the Pythagorean theorem still holds true. So if this is A and this is B, or vice versa, it really doesn't matter, we can say that the square of the cosine plus the square of the sine equals 1. Now, because sine is size agnostic, meaning it works for any size triangle, this will actually lead us to one of the identities. So we can say sine of A squared plus cosine of A squared equals 1. And this is a very powerful identity. This is what's called the Pythagorean identity for trigonometry. Sometimes you'll see it written this way, and sometimes you'll see it written this way. Sine squared of a plus cosine squared of a equals 1. Right? So there's a couple different ways to write it, but that's the trig identity that I wanted to show you. So how can we use this trig identity? Well, you can see it listed up here, right? Sine squared theta plus cosine squared of theta equals 1. And I'm going to show you how you can use it, one of the ways you can use it, as you're figuring out different things. You know, you might want to figure out sine, or you might want to figure out tangent, or whatever. You can use this identity as a tool to figure out different things. So let's just go ahead and answer this first exercise just to give you an example. It says here, if cosine of theta equals -2/3 and tangent of theta is greater than 0, show how to find the value of sine and tangent using the Pythagorean identity. So we have here cosine of theta equals -2/3. So we know that sine squared of theta plus cosine squared of theta. Now we already know cosine of theta is -2/3, so we're going to square this, and that's going to give us 4/9 equals 1. So we're using the square of the cosine that was given, because sine squared plus cosine squared equals 1. Then we can subtract 4/9 from both sides. You get that sine squared of theta equals 5/9. So that means that sine is going to be the square root of this. Now, normally, if you're taking the square root of both sides, we would say it equals plus or minus the square root of 5/9. However, it does say that tangent is positive. So what that means is tangent is only positive in 2 sections. Right? So tangent is only going to be positive here or here. Now, we already know that cosine was -2/3. And cosine is only negative here and here. That means we must be living in this quadrant. And in this quadrant, sine is also negative. Okay? So that means even though we've got plus or minus the square root of 5/9, we're actually going to choose the negative of that. So sine of theta equals negative square root of 5/9. So square root of 5. And then the square root of 9 is just 3, so we're just going to write it as -5√3. Okay, that's going to be right in here. -√5/3. Now, tangent is just sine divided by cosine. So that's -√5/3 over -2/3. So the denominators cancel out, they divide out. So we get -√5 over -2, which is just -√5/2. Positive, excuse me. Positive √5/2. So that's just an example of one way that you can use the trig formula, or the trig identity there. We used it in this case to figure out what sine was given a specific cosine. But you can use it a lot of different ways as well. I hope that helps you understand this Pythagorean identity for sine and cosine. Have a wonderful day. Please like if this video helped you and subscribe because that helps the channel. And I hope you have a great day.